Well, welcome back, everyone, to the Social Contract Research Network seminar. This is our second seminar for this semester. And today we're taking a deep dive into what must be two of the most consequential questions related to the social contract. There's the question of what or who precedes a social contract, who is capable of entering into a social contract. And then there's a question of to what extent is a stable notion of the common good achievable, especially among subjects who are, as our speaker today, I'm sure will explain, at odds with themselves. What can the common good possibly look like in such a situation? And to lead us through these questions, and no doubt others besides, it is our great privilege today to be joined by Timothy Jackson. Timothy is co-head of the Australian Venom Research Unit at the University of Melbourne and brings, in terms of this seminar, a unique perspective, I think, to the questions that we're wrestling with. Timothy's title today is Diverse Relations to Alterity, Collective Individuation and Subject Groups in Simondon, Guattari and Chemical Ecology. So please, would you join with me in welcoming our speaker for today, Timothy Jackson.
Thanks so much, Chris, for that introduction. Continue to share. Okay, can everyone see the presentation? Wonderful. So I've changed the title ever so slightly, and I will be touching on all those issues that are in the abstract. But yes, a lot more besides, and perhaps we can, in the discussion, return to those themes and sort of draw them out if they are even underemphasized. In this talk, which I will apologize for up front, contains far too much and is not well enough structured probably at this stage to justify that amount of content. So it might be a little bit of conceptual overload, but hopefully we'll work together in the discussion, or you guys will help me out, basically. Because this is a relatively new thing for me, which is to take a bunch of things that I am generally working on and apply them to this sort of social contract theory context. And so again, thanks so much to Chris for the invitation to do that. And my final apology, actually it may not be my final apology, but will also be to say that I'm not very familiar with the social contract literature in general. So I'm going to talk a little bit about Hobbes just to start off, and it might be a little bit sort of undergraduate level for this audience, but then again, hopefully we'll get into some other areas in a bit more detail. So the new title is Diverse Relations to Alterity, same title, but subtitle a little bit different, From Relational Physics to the Transindividual. Okay, here we go. Okay, so really brief overview. Talk a little bit about Hobbes. We'll talk about frustration and relational physics. We'll talk about individuation according to Simondon. We're going to talk about life a bit and how it's technical but not mechanical. A bit of chemical ecology with both Guattari and Simondon again. Technicity and automata, the transindividual dimension of Simondon's thought, and a bit of a rejection of the need for a Leviathan there at the end. So the world according to Thomas Hobbes, again in very brief, and this is something you guys can school me on a little bit more towards the end, perhaps in the discussion. But I like this idea that I came across in the introduction, actually, to the Oxford World Classics edition of the Leviathan, that Hobbes affirms a one-world realism, right? So it's allegedly materialist ontology and close to the Greek atomists in some ways, according to Gaskin's arguments. So it's essentially deterministic, bodies governed by impulses. The right of nature is to do whatever is in accord with the impulsions of nature. Life is a race. We must suppose to have no other goal nor no other garland but being foremost. To continually outgo the next before is felicity, and to forsake the course is to die. So these are Hobbes' images, of course, of the state of nature. And this, of course, can lead, all this competition of individuals amongst themselves with one another can lead to the state of war, of all against all, and as Hobbes describes as the greatest evil that can happen in this life, something we all certainly want to avoid. The remedy, as you know, is attention to the laws of nature, These are essentially eternal, and human nature is taken to be constant, I think, and they're God-given. The laws of God and the laws of nature do coincide. Basically, we should seek peace where it can be found, but defend ourselves if it cannot be. And there is this distinction that Hobbes makes between our internal and external sort of drivers here. So whilst we wish as isolated individuals, so in foro interno, to follow those laws of nature, to seek peace, in nature we can't always do so because others might not, and we might be vulnerable to exploitation. So externally, we might be forced to do otherwise than seek peace. And of course, the Leviathan, by virtue of a sovereign authority that binds the social body or the body politic together, that body politic ends up functioning as an automaton with artificial life. Okay, so ostensibly, Hobbes was looking at the science of his time and trying to derive an image of nature from that science. But a big part of what I'm going to be talking about today is whether that image of nature really stacks up with what we think, if we can be defined with any kind of consensus about nature today. So we're going to start with this slightly tricky concept, but of frustration in physics. It's tricky, but actually it's also very intuitive because it's not dissimilar. I mean, there's a reason they call it frustration, right? So in many body physics, and as described in statistical mechanics, frustration is really what leads to the origins of any complex structure. Basically, relational constraints amongst constitutive entities, so all the parts of a many-body system, they prevent energy minimization. So in principle, every part wants to go and seek its energy minimum. It wants to seek a state of equilibrium. But because there are other parts in the way, essentially, there are other entities that comprise this many-body system. Not everyone can do that all at once. They're blocking each other from doing it. Conflicting drives get in each other's way. So that means that even at absolute zero, at the lowest possible temperature, there's a so-called rugged energy landscape or a degenerate ground state. I'm not going to unpack necessarily a lot of this stuff, right? So I'm going to rush through a lot of content here, and then if there's interest in the end, we can examine some of these things. But basically, entropy can't be minimized or maximized in these frustrated systems, right? Intuitive examples would be things like sticks in a bag, right? If you had a bunch of sticks in a bag and you put the bag on the ground, all those sticks ostensibly want to seek their ground state. Gravity dictates they all want to lie down flat on the ground, but they're all going to prop each other up in different ways. You know, some might be on the ground, but they are going to prevent others from reaching that ground state, right? So very straightforward and intuitive. Or maybe particulate matter running down a plug hole, different bodies in amongst those particles are blocking each other, maybe blocking up the plug hole altogether, and you get some kind of emergent structure at the top of that plug hole, where in principle everything should just run down it. Now, this can be generalized and glossing over all sorts of devils in the details into a kind of relational ontology in fundamental physics. So it's arguable, and it would be vociferously argued, I'm not going to claim otherwise, but that there's no structure at all in physics without relationality. So paradoxically, and we'll get into this probably a bit with Sim and Dunn, but this is something we could discuss later, relations and terms have a kind of simultaneous origin. So you don't have relator that enter into relations. Relations constitute relator. But I don't think it would be quite right to say that relator, as is often said in process relational ontologies, that relator, that relations precede the relator. There's a kind of simultaneous origin here, but it's a difficult thought, right? So we could talk about relational quantum mechanics, where discontinuity is the result of interaction, like a measurement. You have a continuous state described by a Schrodinger equation. You have observation or measurement, which leads to the so-called collapse of the wave function, leads to a determinate outcome. That's the origin of discontinuity in quantum mechanics there. But also where there's already frustration existing with many body systems, an external driver like temperature or energy gradient can induce this phenomenon that's often described as self-organization. And there's a picture here of a very famous example of a dissipative structure described by Ilya Prigogine. These are Bénard cells in the image there. we want to problematize maybe up front this notion of self in self-organization. The process is incurably relational, so it's a many-body system again with lots of parts interacting with each other, and it's heteronomous. Really, the system is open. Like there is this gradient that in this case is actually running through the system. If you were thinking of something like a Bénard cell, right? In the absence of like the temperature gradient in the Bénard cell example, you wouldn't get self-organization, right? So this is something that is open to an alterity, which is influencing its organization, let's say. And so crucial concept for Simondon is this notion of metastability, which he's also getting from thermodynamics. Basically, a metastable system is avoiding collapse to the absolute surface of stability. Maybe an intuitive or an example that people would be familiar with there is the so-called heat death at the end of the universe, right? But basically equilibrium again. A metastable system potentially maintains itself far from equilibrium as long as it has access to an external source of energy, and this can enable ongoing change. Okay, that's enough physics for now. Gilbert Simondon. So one of the other problems with this talk, here's another apology, sorry, is that it's not really explaining complicated things in terms of simple and familiar things, so much as like stacking complications. But so individuation, right, in Simondon's philosophy. So Simondon would say ontogenesis is first philosophy. So even before ontology, you need to think about ontogenesis, the genesis of being. There's no individual or individuated term prior to a process of individuation for Simondon. And he thinks that the big issue with the history of philosophy is its inability to think individuation in the absence of pre-constituted individuals. Structure is secondary to operation here, and transmission is secondary to transduction. So transmission, you can think of things like the kind of billiard ball mechanics of sort of Newtonian classical mechanics, things banging into each other. There's a force transfer, but those things, right, those quote unquote billiard balls are pre-constituted in that model. A kind of relational process of mutual structuration, which could be described as transduction in Simondonian terms, is actually necessary, Simondon is saying, in order to get those individuated billiard balls that then can bang into each other and transmit. There are three orders of ontogenesis or individuation, you might say, in Simondon's philosophy. This is how my very good friend Jason Tuckwell, who's Simondon's scholar, thinks about things. There's becoming in general, and then there's the becoming of particular beings and the becoming of relations between beings. And again, those to me, even though Simondon himself will say that relations precede relata, I think in an important sense, the genesis of particular beings, say of individuals, and relations amongst them, that arises simultaneously. These also aren't necessarily sequential terms. The devil's in the details again here, but they're interoperable terms. And as I've said, particular beings and relations between them have a sort of simultaneous origin. Individuation occurs differentially across domains. So Simondon will describe physical individuation, vital individuation. Technical individuation is something nested within the life world, as we're going to get to. Psychical individuation and collective or trans-individual individuation. So the basic schema that is essentially similar across those levels, but the actual concrete manifestations of it are very different, and the diagram, so to speak, is modified in different domains, is one in which there is a pre-individual field, which is pre-phasic, so-called problematic field. There are tensions that arise in this field, resulting in disparation. And the individual emerges as a kind of mediation and a provisional solution, not a synthesis. Simondon is very keen to disambiguate his system from Hegel's, establishing communication between these orders of magnitude that have separated in this disparation. And it can also include the origin of a novel domain that encompasses and exceeds the disparate preterm. So if you imagine a kind of landscape, it's a continuous landscape. There aren't discrete terms in it, but you can get something like a gradient, there's a disparation between, say, something at the bottom of the hill and something at the top of the hill. There's a breakdown in communication between these things, Simondon would say. The individual is a structure that emerges to put these two disparate elements of that primordial continuity back into closer communication with each other, and that is the origin of a structured individual for Simondon. And it's also the origin of phases, so it's not merely a phase transition as a phase transition would be described in statistical mechanics and its various derivations. Okay, so now we will take a little detour into the thought of Georges Canguilhem very briefly. And this underpins a lot of Simondon's thinking. Canguilhem was one of his supervisors and very, very influential on him. And so what we're developing here is a critique of the mechanical philosophy or the mechanical model of organisms and really of ontology in general. But so Canguilhem will say it is certain that for vitalists, the fundamental biological phenomenon is the phenomenon of generation. Vitalists have confidence in the spontaneity of life, which is going to be important. Vitalism translates a permanent exigency of life in the living, and this explains this characteristic that mechanists, biologists, and rationalist philosophers criticize in vitalism, which is its nebulousness or its vagueness. If vitalism is always an exigency, it is normal that it would have trouble formulating itself in terms of determinations, so Canguilhem says. So again, people who are working according to the mechanical model, which presupposes discrete terms, may criticize what Canguilhem would think of as vitalism for its vagueness. But Canguilhem is sort of saying that's not a bug, that's a feature here. And any theory, and this actually includes Darwin, and I normally talk a lot about Darwin in these contexts, but I've left him out of today's talk really, but we can talk about that if people would like. Any theory that takes spontaneous variation as its first term must forgo pretensions to complete explanation is part of the point here. There's not going to be any closure of explanation or complete knowledge if variation or spontaneity is, in some sense, first what makes any kind of structure or any kind of knowledge possible. So it's going to exceed knowledge essentially by definition or by postulate. So the classical vitalist accepts the insertion of the living organism into a physical milieu to whose laws it constitutes an exception. So Canguilhem is saying that there is this conception of life as this kind of island of difference within a landscape or a sea of invariance, which is the physical milieu. But Canguilhem thinks this is the philosophically inexcusable fault of classical vitalism. It sins, paradoxically, he says, only in its excessive modesty and its reluctance to universalize its conception of experience. Once one recognizes the originality of life, one must comprehend matter within life and the science of matter, which is science itself within the activity of the living. So remembering that for Canguilhem, what is characteristic of living is generation, and spontaneity, Canguilhem is really saying here that rather than life being this exception to the physical laws and physical invariance that holds generically, in fact, physical laws, physical invariance are in some sense an achievement within a broader phenomenon of generation or spontaneity or quote unquote life. Simondon, who would not, unlike Canguilhem, unlike his teacher Canguilhem, would certainly not describe himself as a vitalist, makes some key distinctions between the vital and the physical, but they're not the ones that Canguilhem is criticizing. So Simondon will say there is a domain of knowledge of the physical and a domain of knowledge of the living, but not in the same sense a real domain of the physical and a real domain of the living, separated by an equally real boundary. The physical and the vital are distinct according to structures and functions without being separate according to the substantial real. And that last comment, the substantial real, is really important here. This is an anti-substantialist argument. There's not a substantial distinction between life and non-life, and certainly not a substantial distinction, say, between like mind and matter in Simondon, but there are operational distinctions. These things behave differently without being substantially different. So here's the operational distinction between the vital and the physical. Physical individuation is considered as an individuation that jumps the gun, does not sufficiently remain in suspense at its origin. vital individuation would be like a dilation of the inchoate stage that makes possible an organization, a deepening of the extreme beginning. So vital individuation preserves that pre-individual problematic or a relation with the pre-individual in the individual itself, or the individual is always in an ongoing relationship with the pre-individual, so that basically it can keep individuating, whereas physical individuation is kind of one and done, according to Simondon. So life and non-living matter, in a certain sense, can be treated as two speeds of the evolution of the real. And physical evolution then occurs very rapidly, whereas living evolution or vital evolution is ongoing. So in some sense, it's always deferring its end, right? It's open-ended. He goes on. Biological individuation does not fully resolve tensions. It leaves the problematic latent, subsistent. It hasn't resolved everything. We have tension and potentials for becoming other, for recommencing an individuation is not destructive of the first. This force itself is not vital, it is pre-vital. So microphysical reality, or the pre-individual, is pre-physical and pre-vital. So Simondon would think it was a category error to suggest that, you know, life emerges from the physical or the physical emerges from life. He's saying that what's primary or primordial is both pre-physical and pre-vital, since it's pre-individual. And vitality and physicality evidently characterize individuals. Above this scale, this physical individuation, when the system is capable of receiving information a single time, then develops and amplifies this initial singularity by individuating in a non-self-limited way. If the system is capable of successively receiving several inputs of information, of compatibilizing several singularities, then individuation is vital, self-limited, and organized. So basically, if the system is in fact still open to further information, so further kind of transformative relation with alterity, as we'll see, then it is a living system for Simondon. Technicity, of course, very important for Simondon, very famously. The technicity that manifests itself, more quotes, there's a lot of quotes in this talk, itself in the use of objects, provisionally resolves problems posed by primitive and original phase of man's relationship, but it creates more problems, right? It doesn't stop coming into being, doesn't stop at the discovery of technicity. From being a solution, technicity once more becomes a problem when it reconstitutes a system via an evolution. So again, technicity, technical objects, etc., are internal in an important sense to vital individuation for Simondon. Technicity is never to be considered an isolated reality, but part of a system. Being the result of an evolution, technicity is also the depository of a capacity to evolve. So again, just trying to keep in mind, we're developing a critique of the mechanical philosophy here. And of course, technicity is very related to the origins of the mechanical philosophy, or what the mechanical philosophy bases its model of reality on. Technicity is heir to a capacity for evolutionary divergence. And so techne, in general, is a reproblematizing of the primary problematic, essentially, right? So Jason Tuckwell will call it a deviation, and I would say that that's acting on primary deviance. So you have this primary variation, and techne is a way of sort of intelligently tapping into that, you might say, as opposed to simply being pushed by so-called, you know, causes a tergo, causes efficient causation from behind. Techne is deviating. So techne and agency are going to be very closely related in this conception. And Simondon has a critique of automatism, remembering that I think Hobbes only mentions the automaton, the Leviathan as automaton, directly once, but there are arguments that he was very influenced by automata in his development of the context, the concept. And this ends up being quite resonant with or relevant to Simondon's critiques of automatism and his critiques of cybernetics, which he is nonetheless heavily influenced by. So he says, worshippers of the machine commonly present the degree of perfection of a machine as proportional to the degree of automatism. Blah, 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 blah. They think you could interconnect all machines amongst themselves in such a way as to constitute the machine of all machines, which does kind of sound a little bit Leviathan-y. But he's saying here, very long quote, automatism is actually a rather low degree of technical perfection. To make a machine automatic, you actually have to sacrifice a number of possibilities of operation, as well as numerous possible usages. It can only do what you've put in it at the beginning if it's a closed automatic system, basically. Um, so automatism and its utilization in the form of industrial organization, which one calls automation, possess an economic or social signification more than a technical one. He says the true progressive perfecting, he does, wax pretty Hegelian at times, of machines, whereby we could say machines' degree of technicity is raised, corresponds not to an increase of automatism, but on the contrary to the fact that the operation of a machine harbors a certain margin of indeterminacy. So an automaton here is conceived as a closed, determined, predetermined system that's just acting out whatever is put into it. It's closed. It can't take ongoing influence from the environment. It can't receive information because it's this margin of indeterminacy that allows the machine to be sensitive to outside information so that the machine itself can take part in a kind of ongoing process of being informed. So it can potentially become plurifunctional or whatever. A purely automatic machine, completely closed in on itself in a predetermined way of operating, would only be capable of yielding perfunctory results, right? Again, it can only do what you've put in there at the beginning. And in fact, I'm not going to develop this, but there's an important critique here. Automatism is kind of a stack of shonky abstractions. First we build machines in the image of life. This is part of Canguilhem's argument. In order to build a machine, you first have a living organism that does certain things. An ox that pushes a wheel or whatever. Then you build a machine that can replace the force that was originally provided by some vital system. You build machines in the image of life. Then we retrospectively understand living systems in terms of the machine metaphor. Then we build automata as imitations of that mechanical image of the living system. So we're getting very confused here. But the key point, right? Living systems are not closed. They do have agency, but not naively conceptualized autonomy. And this is a critique of cybernetics, as we're going to see as well. But open question I'll leave here. Where do humans treated as sovereign, preformed individuals fit in all of this? There is a kind of image of the human as a certain kind of automaton in the mechanical philosophy. And really everything is an automaton in the mechanical philosophy. The whole cosmos is an automaton, right? According to the famous Laplacian thought experiment. Okay, we're going to take a turn now into chemical ecology. We don't necessarily need that quote. I'm going to have to skip some quotes. We are going to be thinking a little bit with our friend Felix Guattari here, as well as, of course, Simondon. But what is ecology anyway? Was the term ecology was coined by Ernst Haeckel in 1866. It's a combination, it's a neologism, right, with Greek roots, oikos plus logos. This is the study or order of the home. Oikos is the home. Haeckel defined it as the science of the relationships of the organism to its surrounding world. You can compare this with oikos nomos, economy, which is management of the home. So to what extent ecology can be generalized is, I guess, a subject of much discussion and debate and has been for a long time. It's a science of relations or a science of context. And context really is comprised of organic and inorganic relations that an organism has. I mean, how general can you go? Process relational metaphysics is famously based on a generalization of ecology. Can we think about ecology of molecules? We certainly can. It's something I think about a lot, and we'll talk about a bit more. Ecology of ideas. Are these just metaphors? But the real question here is, what would be the consequences of a shift in emphasis from entities to relations? So of adopting an ecological stance towards nature and culture, if we acknowledge that distinction in general. So what's context? Really basically, these are definitions I originally got from Wikipedia, but the circumstances that form the setting for an event, statement, or idea, and in terms of which it can be fully understood. I think fully understood is a bit of a problem there. It's the parts of something written or spoken in the linguistic context that immediately precede and follow a word or passage and clarify its meaning. Okay, words in isolation without linguistic context are meaningless, right? So words only have relational and context-dependent meanings, which is kind of elementary. There is this transcendent role of context in some sense in a relational view, in a generalized ecological view, the only kind of context-free principle is the role of context. There are no context-independent things, no related without relations, as we've sort of already said. But things must be more than their contexts, or they cannot change. And I've sort of slightly tongue-in-cheek said, see dictionary entry primordial excess. Again, that's something we can talk about in these various contexts. So ecology and evolution, I was defined as sciences of context. Some beautiful art from Ernst Haeckel himself there. Ecological context is contemporary. Synchronic context, what are the current relationships an organism is involved in, defined by, or comprised of? Can be thought of in rhizomatic terms if you are Deleuze-Guattarian. An evolutionary context, evolution is no less a science of relations, is historical. It's a diachronic context, so an organism context in an evolutionary lineage. It's tree-like. The environment is that which selects organismal traits. And indeed, this is basically where ecology fits in with evolution. The environment is comprised of organic and inorganic components. Organisms select for other organisms. Niche space is reciprocally defined by other organisms in an environment. There's interdependence and relationism here, right? These are the key points. Organisms and even molecules are what they are, both diachronically and synchronically, because of relations. There's really no other way in biology to understand why an organism has the form that it has, or indeed why a molecule has. They can't be explained in isolation, but only as interdependent with their environment, which includes both other organisms and even their own innards. All evolution is co-evolution, right? So in chemical ecology, which is my primary disciplinary wheelhouse, ecologies are shaped, coordinated, and managed, perhaps you might say, at all levels using molecular means. From pheromones to toxins, organisms use exochemicals, so chemicals they put on the outside, exo, of their own body, to influence and manipulate one another's behavior and even morphology. So this is everything from bacteria inducing choanoflagellates to form multicellular colonies. So over here, the picture we have is of a choanoflagellate that lives as a single-celled organism unless it comes in contact with a particular bacterium and gets a particular effector molecule from that bacterium, which induces it to form a multicellular colony. And this is actually very, very common in nature. We could discuss examples. Myriad marine invertebrates are induced to undergo metamorphosis by bacterial metabolites they can't produce themselves. And this extends all the way, in my conception of chemical ecology, to the usage of molecular tools like drugs by humans, but not only. And tool use is literally economics, the management of the home. So Guattari says in Machinic Heterogenesis, chapter 2 of Chaosmosis, that common usage suggests that we speak of the machine as a subset of technology. We should, however, consider the problematic of technology as dependent on machines and not the inverse. The machine would become the prerequisite for technology rather than its expression. Now, there's a unique and different from Simondon, really, conception of the machine in Deleuze and Guattari, as you probably know, as you may know. But key point here is thinking about toxins and really other exochemicals, but potentially as technical objects. So according to the Guattarian line of thinking, that nature is machinic and life is technical is a prerequisite for human techne. And this can be in a very direct sense that the development of human technical objects often is reliant on accumulated natural work. So we take models from nature, or we just take things directly from nature and deploy them as tools. Toxin, like drug and pharmacon, is a very ambiguous term, very, very context dependent here, not only in the language, not only on the linguistic side of things, but really on the bioactivity side of things. So whether something is toxic, a molecule is toxic, is what I call a context dependent property, right? Toxin resistance and toxin sequestration are widespread in nature. The examples here of these organisms, the wanderer butterfly, the tiger keelback snake, the strawberry poison dart frog, and the Chromodorus nudibranch, these are all examples of organisms that become toxic by feeding on other toxic organisms, whether it's a plant, the milkweed in the case of the wanderer butterfly, or whether it's a sponge in the case of the Chromodorus nudibranch. It's toads for the snake, it's ants for the frog. And they sequester the toxins from those. They're resistant, of course. Those toxins do not harm them much. And they sequester, they store those toxins in specialized tissues to become toxic themselves. They're all brightly colored. That's aposematic coloration. That's saying, don't eat me, I'm toxic. But again, none of them produce those toxins themselves. One organism appropriating another organism's bioactive molecules for its own use, right? This abstraction of the molecule from its genetic context is the origin of a technical object. A trait is not a tool. These toxins are traits of the organisms that produce them, but they are not exactly traits of the organisms that appropriate, co-opt, or abstract them. They're technical objects, I'm arguing in that case. They're more like tools. Humans do something similar. We call it pharmacology. This is, of course, how pharmacology began, finding useful molecules in nature and putting them to our own ends. So tool use is common in nature. It's a form of exaptation. It's using something that evolved for one purpose or indeed no purpose at all for a different purpose. Got a capuchin monkey cracking rocks here. There's really a kind of hammer and anvil or mortar and pestle kind of situation. You can't see the other rock, but there are two rocks being brought together here to crack nuts. A corvid there, like a crow, using a little twig to extract beetle larvae. And there are just myriad examples. We could just list many, many examples. So using something that evolved for one purpose or no purpose at all for a different purpose, repurposing, co-opting, this is what we call exaptation in evolutionary biology. And there's an objectification or abstraction going on here. The objectified or abstracted tool or acquires a form which is determined through the distant purpose of its use, right? This is definitional of the origin of a tool. This is a quote that I've taken from Gotthard Gunther, who has absolutely no idea or had absolutely no idea about how widespread this was in nature. He thinks animals don't do it at all, but which is completely wrong. But nonetheless, he has a nice little definition there about acquiring a form determined through the distant purpose of its use, right? That is, again, co-option or exaptation. And as I've said, toxin sequestration is tool use, pharmacology is tool use. But a technical element, according to Deleuze and Guattari, remains abstract, entirely undetermined, as long as one does not relate it to an assemblage it presupposes. It is the social or collective machine, the machinic assemblage, that determines what a technical element at a given moment. What is a technical element at a given moment? What is its usage, extension, comprehension? Again, context dependency. If you consider the abstracted technical element or technical object in isolation of an assemblage, well, you can't say what it is, what it can do, etc. It's only when it's plugged into an assemblage that it has those kinds of properties. This is very much the case for molecules in general. The function of a protein is fundamentally relational. Right? Protein on its own just doesn't do anything. It must interact with another protein, generally speaking, in order to affect its functional role. This is true for the proteins and other bioactive molecules in your own body, the endophysiological molecules, as well as the exophysiological molecules like toxins and pheromones and things. We won't talk about animism in this talk. There's too much. Exophysiological proteins, as I've said, find their targets in the body, i.e. the physiological system of other organisms, and that's, toxins, pheromones, etc., as I've said. So a really important principle here in evolutionary biology and in ecology is that a change of context, so a change of sort of embedding relations, may enable a change in function. This is just an incredibly important way that evolution operates. But I'm going to have to race through it, as with everything else. When a protein enters a new environment, a new context, it encounters novel interaction partners, right? Other proteins and things that it might be able to interact with. And it's important to note that proteins and other bioactive molecules, including drugs, no matter how well designed those drugs are very profligate in their interactions. They're sticky. They stick to all kinds of things, right? There's no sort of one-to-one stereochemical relationship between, say, a toxin and its target. Toxins will stick to all sorts of things. And that's one of the ways that new functions emerge. Stochastic gene expression facilitates this. It's a source of primary variation. Injection into target organisms facilitates this, and indeed ends up facilitating the coevolution of proteins and delivery mechanisms like fangs. This is milking a spitting cobra in sub-Saharan Africa. They're very, very specialized dentition. They can spit venom as well as inject it. And there is a coevolution of the proteins, the toxins that are the constituents of those venoms, and the delivery mechanisms themselves. When a gene structure changes, that also changes its propensity to interact. That results in novel so-called affordances. The ecology can change. The set of interactions can change even here without a change of location per se. Point mutations can cause this. There are molecular and organismal analogies, which are important here. But generally speaking, in evolution, when constraints are reduced, rapid change can occur. This can be referred to as escape from adaptive conflict in the molecular case, and escape and radiate coevolution in the organismal case. Distinction, okay, back to Deleuze and Guattari. The distinction we'd like to propose between a machine and an assemblage. A machine is like a set of cutting edges that assert themselves into the assemblage undergoing deterritorialization and draw variations and mutations out of it. There are no mechanical effects. Effects are always machinic. In other words, depend on a machine that is plugged into an assemblage and has been freed through deterritorialization. Key distinction between Deleuze and Guattari's conception of the machinic and the sort of mechanical view or the mechanical philosophy that we're critiquing here is that the machinic is, again, incurably relational. There's no real determinism of effects, actions, behaviors, etc. here. What you do, or what the machinic element does, is very much dependent on the set of relations that it's in, as we've discussed a number of times already. So this can lead to a paradigm in disruptive pharmacology, but toxins mediate antagonistic encounters by entering the physioeconomy of target organisms and reorganizing it, disrupting set points, occasionally installing new ones. You can get a symbiotic slippage from antagonism to mutualism. Sometimes, say, parasites evolve into obligate symbiotes and things like that. This can constitute novel assemblages, indeed even novel organisms, with endosymbiosis as the limit concept here. This is a transition from a disruptive influence of a so-called exochemical to a normative influence. The novel physioeconomy is now maintained by the chemistry that disrupted the old one. And this can underlie a transition from something that's an alterity to something that is an interiority in some sense, from exo to endo, from ecology to physiology. We can talk about this a lot in terms of the impact of drugs on society, but we won't. Okay, part of the critique of cybernetics that comes in here, and there is a relationship or a conceptual resonance between the Hobbesian view and the cybernetic view, involves a critique of autopoiesis. Guattari initiates this when he says that autopoiesis, which uniquely defines autonomous entities, unitary, individuated, like pre-individuated, and I've added organizationally, closed to input-output relationships, lacks characteristics essential to living organisms, like the fact that they're born, die, and survive through genetic phylums. Autopoiesis deserves to be rethought in terms of evolutionary collective entities which maintain diverse types of relations, this is the key quote from the title, to alterity rather than being implacably closed in on themselves. So against autopoiesis, which defines organisms as organizationally and/or operationally closed, but thermodynamically open, saying they're not organizationally or operationally closed. In fact, they maintain diverse types of relations to alterity, as Guattari memorably says. They're constitutively open to reorganization and information by the other. This is, of course, related to Simondon's critique of automatism and the automaton as closed to information, as predetermined. So you get a conception here where machinic animism is pitted against autopoietic autonomy. This is another point for theoretical biologists, issues aren't resolved by the organizational account, which did try to reform autopoiesis, but still has issues, in my opinion. Okay, there is still quite a bit to go, but I know I'm running low on time here, so I'm going to try and wrap this up pretty quickly. Abstraction is an important concept that's been lurking underneath this whole talk. I mean, I haven't even got to the transindividual in Simondon yet, which is a lot. So I probably will have to skip over that and we'll jump to the discussion points. And maybe another time I'll talk about the transindividual in more detail. But abstraction, here's Alfred North Whitehead, who's going to come in and talk to us about abstraction in a moment. Closure is a property of abstract objects. Objects do exist in nature, for sure, but they're objectified in relation. Objecthood is operational. The mechanical philosophy, including autopoietic theory, which is sometimes considered a critique of, well, it is a critique of computationalism and certain other so-called mechanical paradigms, but is itself, according to its inventors, Maturana and Varela, a fully mechanical theory, reifies this abstract principle. So it projects a property of an abstract object or a formalism onto nature and says that's how nature is. Effective theory, which is really, again, there's a whole sort of genealogy of the mechanical philosophy to discuss here, and Laplacian methods in physics and how they come into biology and things. But I'm encapsulating that as the notion of effective theory. We can talk about that. It deploys a primary abstraction in service of instrumental ends. As traits are not tools, neither are individuals abstract objects. So there's a confusion here, which I'm saying exists, I think, in the broadly Hobbesian characteristic of the autonomous, closed, preformed individual that subsequently enters into a relation, right? It's a confusion that comes from his study of basically mechanical science. They maintain a relationship with a pre-individual milieu, right? Individuals do that, that is, especially vital ones. Alterity exists both externally and internally, which Chris mentioned right at the beginning, and I'm only finally getting to vital individuals, which are more than a unity for Simondon, right? So primary variation is always excessive to its inframing, let's say, by an organism. There's a bit of Heideggerese slipping in there. Simondon has a great critique of the Heideggerian concept. It's not explicitly formulated as such, but of the Heideggerian conception of techne. Whitehead has to say here that abstraction expresses nature's mode of interaction and is not merely mental. When it abstracts, thought is merely conforming to nature, or rather, it is exhibiting itself as an element in nature. So, I put an insert theory of natural abstraction here. This is a really, really crucial part of my ongoing project, but there's far too much to unpack here. Abstraction is something that happens in nature, something that we, as essentially embedded in nature, parts of nature, do. So it's a real concrete phenomenon. But understanding how that works is really important, rather than taking its results like an abstract formalism and then projecting them back onto nature in a kind of uncritical way, or I'll just go with more Heidegger, right? Science doesn't think. That's science not critiquing its presuppositions effectively. Okay, really, really quickly, the transindividual. The domains of individuation ramify in Simondon according to a neotenization. Neotenization is a biological term for the maintenance of a juvenile characteristic into adulthood, of the relation between structure and operation. In vital individuation, the pre-individual problematic is maintained via ongoing relations with the associated milieu, which is a source of difference. The psychical domain emerges as a consequence of the problematic, not resolvable in somatic terms. So this neotenization is progressive, right? There's a maintenance of this juvenile or primordial problematic of the pre-individual that goes on in the vital in relation to the physical, goes on in the psychical in relation to the somatic or vital. Note that psyche and soma, like form and matter, are operational, not substantial distinctions in Simondon, and psyche mediates between world and individual, and the individual here taken as the result of vital individuation. Biological reality is anterior to psychological reality, but psychological reality takes the biological dynamism back up. That's this neotenization point again. The transindividual emerges similarly as a consequence of a problematic that this psychic individual cannot resolve, right? So because we have psychic problems that we can't resolve on our own, there is this need for a transindividual layer of individuation to take place. So individuality is made possible by the prior neotenizations, i.e. by the ongoing presence of the pre-individual to the individual. The associated pre-individual milieus of multiple individuals thus enter into affective resonance in the transindividual, and reciprocal transformations take place. Okay, so there's a whole lot of stuff now about interiority and exteriority groups. I'm just going to skip all of this. Unfortunately, I think there isn't time. If people want to come back to that in the discussion, then we can. But I really want to leave time for discussion. So my suggested discussion points, and there are many here as well, are saying that Hobbes's image of nature is shonky. Science has moved or is moving on. Of course, science is not a monolithic enterprise or a body of knowledge. So there are lots of different conceptions of how contemporary science and the, let's say, Laplacian paradigm in physics interact. There are no preformed individuals. Metastability is always a relational achievement. Okay, I'm saying this. There are no eternal laws. Laws themselves are historical achievements, no individuated terms that are primordial, right? The effective theory paradigm of the mechanical philosophy and rationalist science, this is science where it fails to be thoroughly empirical, actually, has its own contingent historical origins in monotheistic theology and the development of abstract formalisms. There are no absolutely closed systems. This is another idealization. CF steam engine metaphysics, which I can unpack if people are interested. There's no stable common good. Yeah, so I skipped the stuff on common good, so I can come back to that if people want. But as relations constantly change, what is good is irrevocably contextual. As in biological evolution, the context dependence of fitness. But this does not imply abject relativism, right? This is actually a realist philosophy, but nonetheless, it's a realism of genesis first and contextuality first, right? This undermines claims to pre-stateability or absolute knowledge. So there's no stable common good unless it be operationally defined, right? So not change for change's sake, but maintenance of plasticity is crucial. So basically, not preventing the possibility of ongoing evolution or ongoing individuation is the key point here, which is different from giving a pre-statable positive program, which people tend to want, but I'm worried that that's just not possible and inherently kind of authoritarian. There's no self-legitimating sovereign higher power if you look at nature, right? All structure results from immanent relationality. So the excess pre-individual variation is primary in generative ontology. This is also part of my reading of Darwin, which I haven't developed here. Compare with Georges Bataille on sovereignty if you want another reference. The sovereignty of the individual is its associated pre-individual milieu, which enables reciprocal individuation, but cannot be itself enculturated or objectified. Okay, so if I'm gonna stop there. Thanks for your patience, everybody. There is more content if people want to see that, but I just want to leave time for discussion. Shall I stop? Yeah.
Wonderful. Thank you very, very much indeed. I'm just going to switch back to a gallery view here. Thank you so much, Timothy. An incredible amount of detail for us to engage with. Our custom here is if you'd like to ask a question or make a comment, if you could just put one line in the chat so I know who wants to do that, and then I'll call upon people in the order that you send a little message to the chat saying that you'd like to ask a question. That just saves me having to work out who was first. As people are preparing their questions, Tim, I wonder if I could just have the first question. I had a couple that I was going to ask you, but there was something in your closing remarks that I want to pick up on. It's the idea of there being no context independent good. And I just want to test the limits of that claim.
Sure.
Is it not the case that in the biological world, it has to be assumed at some level that, to put it very, very bluntly, life is better than death. And if you don't assume that to be universal, then nothing else sort of makes sense. So that, and that isn't context dependent. It's a thought experiment. Is that a context dependent good? And if not, what context is that relying upon? In what context? What context has to be present for it to be the case that organisms seek life rather than death? I guess is what I'm asking.
That is such a good question, Chris. Of course, I want to just agree with you. because I certainly think life is better than death. Um, and I think, in fact, a lot of the problem that I'm, probably circumlocuting here, but in the critique of the mechanical philosophy, is that it is an image of a dead cosmos, right? That it has confused essentially what is pure product with what is sort of primary and generative, where life would be what is primary and generative, right? And life produces all kinds of things. Um, but there is an interesting corollary or an interesting way of thinking about this, that death is in some sense not necessary. Um, that certain it might be necessary to achieve certain things, but certain organisms sort of don't die, in the sense that they, continually reproduce by scissiparity, or things like planarians, which are incredibly regenerative. You can chop them into 250 plus pieces, and every single one will become, a free living planarian. Not that you can't kill them. I mean, you can kill them, but generally speaking, they are sort of quasi-immortal. Um, and so there is an argument here that death is a correlate. So for Simondon, death is actually a correlate of a certain degree of individuation, which I think we could align with a certain degree of complexity. So in order to evolve a certain degree of complexity, you need individuation, and the individual is a kind of function class for Simondon, which is associated with things like dispersal away from the site of origin, um, reproduction of certain kinds, and particularly ultimately sexual reproduction, even though things like planaria actually can also and are obviously individuated or individualized and can reproduce sexually. Um, and also what you get, and humans end up being, as so often is the case, a kind of quintessential example of this, is that in these highly individuated and complex organisms, you end up getting these. They're not two-stage in the sense that metamorphic organisms might be two-stage or multiple stage, but you get different life stages which have different sort of operational or functional contributions to the lineage, we might say. So the juvenile stage, and this sort of dovetails a little bit with Simondon's discussion of neotenization, but is a stage of kind of hyperplasticity, of exploration and innovation. Whereas the more mature phases are more to do with creating a space or protecting that, and creating more of it. But there's only a certain window that you can, the argument goes, maintain that kind of plasticity. But the consequence of having that very rapid development, and then its necessary kind of ossification later on, which is a turbocharging not only of sort of cultural or developmental innovation, but ultimately of evolutionary innovation over longer periods of time, is in fact the death of the individual. So there is a sense, and it's not, I don't like saying this, but I guess there is a sense that if death is a correlate of a functional strategy, and so is not inherently necessary, there is a kind of good associated with death. It is a necessary consequence of a particular way of doing things. And thus, and I mean, this is even before we get into sort of more psychological arguments, and why, transhumanism of a certain kind might be quite pernicious and all of that, and maybe why. So maybe there is a reason, I suppose, even though, again, of course, for me, I think life is like, unequivocally better than death. There might be reasons why death is actually really important, and so why we wouldn't want to say that it is a kind of unlike, absolute immortality for everyone would not be an unmitigated good. And in fact, maybe we just wouldn't have the kind of complex world that we have, and biodiversity, complex organisms, and all these things, had that been the case. And ironically, we could almost, and I haven't, this is not a thought that I've developed, but we could almost say that imagining that world of just, absolute life almost collapses again back on that image of the dead world, because in a sense, if there is no death, nothing really, there's no struggle, there's no, blah blah blah. If it's just all bliss, I mean, I'm extending on what you were saying, then nothing really happens. And so I don't know.
Hmm.
If,
That's helpful. Much to say, but I see that Alistair would like to ask a question. So Alistair, please go ahead.
Hello, thank you very much for that. That was an enormously stimulating talk. I'm so glad I came along. So now I've got two questions because your answer to Chris's question has created another question. But I'm going to do them in the reverse order so that I don't forget my question, which was very small. But when you were talking about ecology as the study of a science of relations, you talked about the synchronic context as being rhizomatic, and then the diachronic context as being historical, and that's fine. I buy all that. But then when you talked about history, the image that you gave of evolutionary history was a tree-like image, and I'm just immediately stimulated to respond that in Deleuze and Guattari's presentation of the rhizome, in a way, one of the most the easiest to understand kind of pictures of the rhizome versus the tree is the tree of life is not a tree, it's a rhizome.
Yeah, no, I mean, it's a really, really good question and something that's really important to clarify. I mean, so Deleuze and Guattari will say that there are, trees within rhizomes and rhizomes within trees.
Right.
So that's one thing to say. But I think it's more the case that when we look at history, so when we study diachronic relations, we have a kind of massive selection bias, which is everything from things that are completely out of our control, like what do we have access to in terms of fossil record, etc., to an actual selection bias, like now we do most of this stuff with comparative genomic methods, but how many genomes, even amongst extant species, have we in fact sequenced? Well, it's a vanishingly small percentage still. We're completely drowning in data, but in comparison to the potential data there is for reconstructing evolutionary histories, we only have this tiny percentage of it. So when we do that reconstructive historical project, and I think this would apply to history, in the more conventional sense as well, we're always losing so much of that synchronic detail, which is rhizomatic and ecological. You're embedded in so many different relationships that things look more tree-like. Now, they don't look like an idealized bifurcating phylogenetic tree because things don't simply bifurcate. Even when you look at gene duplication, it can be like, whole chunks of the genome or even the entire genome can be duplicated, but sometimes it's one gene becomes three or something. It's not bifurcation per se. And then there's horizontal gene transfer. So you've got lineages coming together often, and we also talked about the endosymbiotic dynamic in evolution. And then again, this is all before we even try to wrap our heads around just the incredible proliferation of informative relations that any given organism is in its actual sort of synchronic ecological context. So I think it's more, so that it's a really important clarification, but it's sort of more methodological in some sense, that when we look at history, it's going to appear tree-like, but it's as though each node in a tree, if you zoomed in on it, would have all of these little branches coming out of it. And in some sense, this also relates to mechanisms of inheritance, so that the individual goes through this developmental process in its lifespan, which involves a lot of innovation, partly on the basis of what the lineage, it inherits from the lineage. And inheritance is itself multimodal. It's not just genetic inheritance, obviously. It's niche construction for all organisms, really, but for some much more than others, for us much more than really any other. Cultural inheritance, all of these different ways that we bind time, to sort of paraphrase Alfred Korzybski. but only some percentage. So the individual then innovates on the basis of all of that. And there's so much novelty in this sort of what I'm characterizing as primary variation or primary excess, that the individual essentially as a intensified locus of life, let's say, is generating in its life. But only some small percentage of that is then able to be transferred, to the next generation, or you might say back onto the lineage, like has this recursive effect on lineage inheritance. So in some sense, we've always got this, like history is lossy, is basically the basic principle here for a bunch of different reasons. So the individual is innovating and reaching out and creating all of these kinds of relations in this very rhizomatic manner. But then when we zoom out a little bit in time and we look at multiple individuals in a lineage, we necessarily lose so much of that complexity that it ends up looking more tree-like. So I'm not saying ontologically evolution is, tree-like as such, even though it is more tree-like than ecology. I don't want these things to be absolutes. I want to say diachronic relationality is more tree-like, both methodologically and I suppose ontologically, whereas synchronic evolution is more rhizomatic. But I don't want to absolutize either of those things. Is that a fair answer?
Yeah, I think I see that. I mean, the tree is becoming rhizome, rhizome is becoming tree at that kind of level. Then yes. I think I'd maybe push back just very slightly on the kind of optical metaphor, right, where it's like, okay, well, it's that our selection bias is such that it looks this way, but then that seems like in a sense it's you're reifying, right? Yes, it looks like that because we're the kind of products that we are that have gone through the particular kind of production process that we have. Right. But then you're kind of reifying the tree-like elements. It is lossy, and there's also debate, as my limited understanding suggests, about the extent of horizontal gene transfer and so on, like how widespread are those mechanisms. But it does seem a little bit like you don't want to just sit on the optic of, it kind of looks a little more tree, so let's stick with that. But in the spirit of uncovering, right, the being sensitive to the maintenance of the pre-individual within processes of individualization, that maybe let's look for it a bit more. But I'm with you. The other question I was going to ask, because Chris just also, I know you didn't discuss any of this common good stuff, but this is a question that has struck me about Deleuze and Guattari in particular. Okay, I buy your response to Chris. You could argue that there's some way in which, kind of individual death is perhaps, maybe it's kind of in process terms a necessary condition for the maintenance of creativity and novelty and plasticity and so on and so forth. But then that seems to push the question back at a value level. Like, is then novelty or plasticity or creativity itself a context-free common good or presupposed value?
Yeah, well, I guess on the one hand, I don't want to just sort of naively endorse that. And I sort of tried to put in that final discussion point, actually, like, it's not change for change's sake, but preserving the capacity to be responsive, essentially. So that an organismal lineage, say, preserves some degree of evolvability, as opposed to what Simondon would describe, what I would just say in biological terms is hyperspecialization. He would call it hypertele, which is kind of cool. It's like being hypertelic, being too directed towards a specific goal. This can be very useful in the short term, but specialized lineages of organisms are at like heightened risk of I see your little comment. Are at heightened risk of extinction, right? So if you can only eat one kind of plant, well, that's awesome if no one else can eat it because it's highly toxic to everyone else. So you found a bit of niche space where there's not much competition. But if that type of plant goes extinct, maybe because humans come in and bulldoze all the places where it grows or whatever, then you are at very high risk of just reciprocally going extinct yourself, right? So what I'm saying is there is a I don't want to be caught. It's difficult. These are all like difficult, like middle ground. Even with the tree thing, you know, I kind of want to go back to that and be like, I'm trying to hold the middle ground here, you know, because also I have a strong critique, which it was implicit. I guess it was explicit, but it wasn't fully developed in this talk, of the effective theory paradigm in physical theory and its, you know, exportation to other domains, whether that's cultural or biological. But I don't want to say that effective theory is not, you know, powerful and isn't actually tracking something in nature. It has a real relation to reality. It's just the way that it refuses to critique its presuppositions and treats itself as essentially primordial or originary. That's the issue. And there's something like that with the tree, is what I'm saying as well. There is actually an ontological difference where, but there's also this methodological thing, and teasing those two things apart becomes really, really complicated. But yeah, so I would say that the only context of Ben and good that I'm, you know, pointing at right now, and I obviously haven't thought about this enough, and I'm very wary of kind of proposing some kind of cultural program or something like that, right? You know, like a positive, like a positive thesis for a, you know, common good. It sounds like a bit dangerous to me, but it's just to say, like, if we don't preserve this capacity for creativity, novelty, innovation, invention, you know, basically ongoing evolution, we're at high risk of extinction. And that seems like a problem, right? So not doing things. So, you know, if politically, and I always think of myself as very politically naive, which I think I probably am, but it's like politically some ultra conservative program, which is preventing, like trying to shut down, you know, change on certain axes, that can't be a good thing in the long term in terms of the model that I would be proposing here. So that's the kind of, you know, it ends up being almost like a, you know, I don't know, it feels a bit trite, like it's a bit of a truism or something, but that's the most I'd be willing to, you know, affirm at the moment.
Well, thank you, Timothy. Alice, did you want to come back on any of that with a follow-up, or are you good? You're good. Excellent. Timothy, I wonder if I could have one more go at the common good.
Yeah.
Because I think it is incredibly intriguing to think of the common good within the context and the framework that you're setting out for us. And two major questions, I think, arise from the way that you're setting things up. They're not questions to you, they're questions that are raised by you. It's how do you determine relevant context for the common good? And how do you determine who or what gets to be part of the common in the common good? Like who's common to what? And in the context of those two questions, I wonder if there is something that, if it's not a universal common good, is functionally or vanishingly close to that in the framework that you're setting up. So there is, at least until now, a common context for everything, which is life on Earth. Like perhaps in the future we'll colonize other planets, who knows? But up until now, everything that has happened in terms of the life that we know has been on Earth. So there is some sort of common context in that sense, and therefore does the notion of a common good become functionally constant or universal, even if it's not logically or absolutely? Like, you know, we could colonize other planets, you know, all of that stuff, fine, but up until now there is a constant context. And is there not also a sense in which it is possible, and no doubt the case on occasion, that, as you said in the response to my previous question, some organisms or species in some contexts may see death as a good thing in some ways, like it might be useful in some ways. But there's always, and this is a hypothesis, there's always a level on which that death is instrumental in serving a greater goal of life. So it's like Dawkins' selfish gene. Like, yes, there's lots of death that happens, but that's not the telos. That there's something bigger going on that death is serving, and that bigger thing is to do with life. And so isn't there, if that's the case, and perhaps it isn't, but if that's the case, doesn't there emerge something that we might think of as like an anhypothetical common good, or like a functional common good, in the sense that all the organisms that may not have done that have died by virtue of not doing that. So just by sort of brute logic, all the ones that are still around are the ones that are seeking life. So there's an emergent common good in that all organisms seek life, not because that's logically necessary, but perhaps because all the ones that might not have aren't around anymore. And so one way or another, you still get to this universal common good through the back door.
Yeah, really fascinating question, Chris. Thoughts that are very, very stimulating. And I suppose one thing that I would probably want to differentiate between, which you have, would be a sort of pre-statable common good and an emergent common good. And then when you get into when that distinction interacts with notions of a kind of global telos, again, I think we're always on a kind of really shaky ground here, you know. So just as we were sort of saying, you know, what's good for the lineage and good for the individual might be slightly different in some sense, right? You know, there are like that immediately makes the good sort of scale relative, and I don't think we need. So if we again being sort of slightly dispassionate sort of scientists or whatever, we don't need to, and I think it's dangerous to say, you know, try and put some notion of value. Like this is where I would have like an issue with someone like Whitehead or something like that. You know, I'm very close to Whitehead in many ways, but that strand of process thought, and of course, no surprise that process theology, you know, is the main, you know, way that Whitehead's thought was developed. I mean, outside of, I suppose, the French context, where a bunch of philosophers are probably more influenced by him than in the Anglophone context. But you know, he wants to say, you know, you need value to be primordial. You need aim to be primordial. You need all these things to be primordial, because in a sense, you can't get value from non-value. You can't get, you know, those are the kinds of things that simply can't emerge. And I want to problematize that kind of assumption, which is not what you're saying, but by saying, well, you know, and again, maybe I'm not, you know, well schooled enough in sort of classical philosophy, but I certainly worry that making, you know, making value primordial or universal always ends up making some particular value, some particular conception of value, you know, universalizing that, and that ends up feeding into your question of like, who is the common and things like that. Are those sorts of moves, like whenever we try to globalize something which actually has a local origin, are we going to sort of de facto exclude some, you know, subset of whatever entities or whatever that we might have had the opportunity to be more inclusive towards? And so I think this is a very wishy-washy answer that I'm giving you, but a lot of the things that you were saying, which resonate with the notion of universality and even a kind of global telos, which you were talking to, you know, I have a lot of issues with Dawkins, but we won't get into that. That he thinks in too classical a way, you know, in many sense, and too mechanical a way, basically, which is very classical. And I do think of the mechanical philosophy as like an offshoot of, you know, monotheistic theology. So I mean, that's another issue altogether. Just as Whitehead is a Christian philosopher ultimately, and I just worry about making those kinds of things primordial and universal. So really, I'm worried, I guess, about the notion of universals altogether. So I want to be realist about generals. So I want to say that there are real generals, but I want to follow Darwin properly, unlike the neo-Darwinians here, where I want to say, well, variation is primary, and generals emerge as kind of, statistical is not exactly the right word, but it's intuitive, clumpings of primary variation, right? So there's a distribution of variation. It's not just like all equal, all variable mush. There is structure in the world, but that structure is not universalizable, always comes secondary to a primary variation. And I think that that's both, like, methodologically, I think that's a very important assumption in just like evolutionary biology, but I also think that's an ethical stance. And I think that's where people like Deleuze and Guattari sort of do take it. Although I think there is a problem, and you guys, can come back on this. There's a problem again that you don't end up with a positive program there, and that can too easily start to sound like change for change's sake. Viva la différence or whatever. Just break down the established order to unleash novel lines of flight, and that's also not what I'm saying. But I'm saying there's some like really difficult problem that I can't resolve in that middle ground. But to me, just to maximize the argument against universals, I really don't like the notion that say, and this was obviously clear in the talk, but like things that have been around for 13.7 or 13.8 billion years, like certain invariants in fundamental physics, which appear to go back kind of all the way, or back to a singularity, back as far as we can possibly see when we reconstruct it. I'm very resistant to taking those as universals. Still, I'm like, no, those are still, by extrapolation from empirical work in other domains, and also by the principles that I'm applying, those are still achievements. They're still generals. They're just invariants. So like you say, all life is a single common origin. Yes, all life is also adapted to physical invariance. So whilst there are lots of different niches and different lineages are adapted to very, very different parts of the world, and are there's all this diversity, all of them are adapted. All life is adapted to those physical invariants which radically precede life, especially if we're talking about life not in the Kungiem type sense, but in the sort of standard colloquial biological sense. All life is adapted to those physical invariants. But then there's a tendency amongst a certain kind of scientist, even, or like biologist or philosopher or whatever, to say, oh well, look, because all life shares these certain properties which are adaptations to and utilization of or exploitation of physical invariants, those are universals. Those are essentially Platonic forms or something like that. I'm like, no, hang on, not necessarily. Not if Genesis also applies to physical invariants. So that's just a bit of a riff on the themes that you were discussing, but I'm just resistant to universality with a capital U, and like the form of the good or something like that. I think that doesn't mean, and you guys have been thinking about this, or you're going to spend this whole semester, right, thinking about it much more than I am in terms of a targeted thinking on the common good. So I can't say I have any well-formed thoughts there particularly, but I am just inherently a little bit worried about the good with a capital G, or the universal with a capital U, or those sorts of things.
Absolutely. I've got one more follow-up that we could probably sneak in before we finish, but I'm aware that I've been hogging the question time a little bit. So if anyone else here wants to jump in, now is your moment. I will waffle on for 5 seconds to give you the opportunity, and if you don't, I will ask my final follow-up, and then we'll let Timothy off the hook. It was just off the back of what you were just saying, trying again just to probe the limits of this idea of non-universality. Where does it lead? What might be the points at which it could potentially become problematic? You mentioned in your previous answer, at one point, I forget exactly what it was, that we wouldn't want to exclude, we wouldn't want to define the common good such that it excludes. And I want to circle back to that idea of exclusion and interrogate the extent to which that is a constantly undesirable thing, or whether that is a context dependently undesirable thing. So is there, so someone comes along that, so someone asks a question in this seminar. Well, I think the common good is the human good. That's it. Full stop. That's the boundary of it. Everything else, all other life is there basically to serve us. What's wrong with that? How is there a sense in which that sort of position would you want to say that there is something inherently objectionable about that position, or does it depend upon the context in which that sort of position is uttered?
Well, you're trying to trap me in universality by saying it's inherently,
I'm not,
but
I'm not. It's not a gotcha. I just want to. I want to find the limits. That's what I'm doing.
is it intrinsically objectionable? Ah, you're a crypto essentialist. Um, because of course I do want to say that it is. Well, I suppose it depends on what you mean by that, doesn't it? And how nuanced is your conception of what, you know, the human good would actually require? Because I would say that, and this is also, you know, pretty straightforward and commonplace, I think, in these contexts, but, you know, a conception, an anthropocentric conception in which the human good is the common good, and that's the limit, hasn't been very good for humans. Like, if we're looking at the near future, right? You know, there are lots of reasons to worry that that kind of exclusionary view, that kind of exclusivity. I mean, we haven't been good stewards, if we're using that, you know, conception. By, you know, by making that sort of distinction between human life and non-life, we have inadvertently, because the consequences of our actions are unprestatable, which is a key thesis here, right? We can't know what the consequences of that move are going to be, because it seemed like common sense and reasonable to say that, you know, humans are really different from animals and they have an ethical status that's different from other organisms and blah blah blah. That seemed really unobjectionable, and there's like a truth to that for sure. But because of that, we didn't understand the potential consequences of acting in accordance with that maxim, and now we've actually, you know, we've endangered our own existence, right? Or at the very least, we've made life miserable for a lot of humans, because again, it turns out when we were thinking about, you know, the human good, did we even mean, you know, all humans, or how do we define human, or whatever? And, you know, it's like, I don't know, you know, what about the 7 million people that die every year from air pollution or something? Like, we don't need to go on. But that notion has always led to a kind of differential, you know, understanding of who was in and who was out. And I didn't get into, and I'm not saying that's necessarily avoidable either, you know, but we have ideals, right? And so we are calibrating our ideals, not saying that in practice, like in practice, my daughter is probably the most important person in the world to me, you know. And you know, and my immediate family and whatever, you know, so I'm going to be very exclusive in the way that I, you know, make available my time and resources and all of that kind of stuff, right? And but I recognize how contingent and context dependent my own sense of what is good is, and I think that's the important move. And so what I didn't get into in the talk, which would have, I just heaped more detail on, but perhaps would have been relevant to this, is, you know, Simondon's distinction between interiority groups and exteriority groups, which he kind of sees as a better way of thinking than the sort of traditional in-group, out-group distinction. It's probably a little bit complex for me, especially as I'm getting a bit tired, but for me to summarize right now. But also his critique of not the notion of the common good per se, but of the form of the good in Gestalt theory. And again, his critique there is basically that Gestalt theory has, and he thinks this is the same with adaptation, as a like with adaptationist thinking, we would say, but that the key is always to try and get to the optimal place where we have pacified essentially all the tensions. We are absolutely adapted, or we have, you know, we've reached equilibrium basically. And Gestalt theory, you know, explicitly takes this metaphor from thermodynamics about reaching equilibrium. Well, it's essentially all the variation has been homogenized, and now we're set. You know, adaptive conflict is completely resolved. And Simondon's like, that is death. that is death, you know. So, you know, at that point, no more change is possible and you're dead. So this is why I did say in the abstract, and probably didn't develop enough, there is this ulteriority internal to the living system as well as external. And those have to come into relation with one another in order for us to learn, basically. But in order for us to be responsive, we have to have some like unpre-canalized grist for the mill variation in our bodies so that we can meet the unprestatable variation coming at us from the world and behave differently, or like respond, basically. And so that's really the general principle here, I suppose. And again, because I'm not explicitly a political theorist or whatever, I don't have programs in that sense, but I'm just like, well, to me, these seem like really general principles. And so if I did have a program, it would have to, you know, somehow conform with that. But I'm aware of the extreme complexity and difficulty there, which is why I kind of don't wade in. I'm like, I don't know.
Which is a lovely poise upon which to draw proceedings to a close. I think, Timothy, you've been extremely generous, not only with your time, but with your engagement with my slightly rambling questions and the other much better posed questions from other members of the seminar. Thank you ever so much. Please join with me, everybody, in thanking our speaker for today, Timothy Jackson.
Thanks very much, guys. Yeah. And if anyone watching or part of the group or whatever wants to email me, my email is at the beginning of on the first slide. So I'd love to continue any of these discussions onwards.